for your introduction, Chairman. And maybe good afternoon, good evening, and good morning. I don't sure yet. Yeah. Should I? Yes, thank you. And my topic is about the core shock TIC, the titanium carbon, and the TiO2, titanium dioxide nanoparticles for the visible and the NIR-driven photocatalysis. Yeah, I'm sorry. Yes. Before the photocatalyst, I would like to introduce why the photocatalyst or why this kind of material is so important and necessary to be just development. And yes, maybe you know about the SDG from the 2001. Here shows the from them. Here shows the energy and the climate. These two is also important during the SDGs. About these two factions, and yes, here show the photocatalyst face to the two problem. One is the energy, and another is the environment problem. When we talk about the energy, to usually know about the energy characteristics. Sometimes the oil is oil from the earth. Recently, yes, we know about the news about the oil price is going up. That means everything in our daily life maybe goes up. Yes, goes to become too expensive. And another one is from the environmental problem, sometimes air and the water, and sometimes the soils. First is the environmental. Is usually know about the new energies. Here show one kind of new energy, like the hydrogen energy. It is a kind of the clean and the environmental friendly energy. It is usually said about this one, but the production of the hydrogen energy is not so kindly maybe. Another one is the environmental problems. Yes, here shows some kind of can use this to solve with the catalyst or photocatalyst, yes. And here also shows some kind of the mechanism, yes. Because this is about the catalyst conference, I think it is not so difficult to claim about this one. So we will skip about this one. Because of the photocatalyst absorb some kind of energy, and then the electron and force will be formed. Something about this one. So we will play the catalyst laws. And because of this, the absorbed energy and the electron loss, usually the research topic will come to the band gap of the photocatalyst and the suppress the recombination during the transfer to the surface of the material. And also as the botanist professor said that the shapes is also important, and the size is also. And we are back to the SDGs about the energy and the environmental. First, two serious problems. We can use the photocatalyst activity to solve these two problems at maybe the same times. Something like the purification with the titanium dioxide, and another one we can use the titanium dioxide, the actions to divide the water into the hydrogen and yes, with the byproduct just of the oxygen. This is very maybe a smarter solution to solve these two problems. With the one kind of the, yes, also this kind of the environmental friendly materials. Yes, this shows some kind of the application of the titanium dioxide. Here shows the titanium dioxide, yes. This will still borrow this one, and the challenge borrows the titanium dioxide photocatalyst that can be focused on the light response, something like visible light and the NIR to improve, to enhance the activity. Another one is suppress the accumulation during the transfer of the electron holes into the surface of materials. And of course, others is sometimes the sharp dependence and the side dependence is also important. Yes. Another one here shows kind of the yes, maybe a kind of the new application of the titanium dioxide, something like the corona. We can use yes the titanium film into the mask, yes, to improve the performance to the corona BB. And another one, we focused on the cancer care, and we can use the US to restrain film of the titanium dioxide activities. And then we also, because of the scan of the humidity, so the NIR responsibility is so important. Here show kind of the yes critical trial about the titanium dioxide in the so about this topic is focused on this one. We want to yes improve developing some kind of the new material maybe to take care of the care or care treat the cancer. This is in the previous work in our labs. Firstly, we developed a kind of the new heat treatment in the carbon powder. So it is very simple and cheap, and to enhance the activity with the narrow band gap and some about the surface narrow side surface structure. Here shows the band gap. The band gap is something like just narrowed into the one electron volt from the almost 3. And so based on the research result, we changed about the material into the nanoparticles. That means with these fabrications, we can use can also maybe to enhance the activity of the nanoparticles. So we designed the research like this one. We just use the TIC nanoparticles, and then we heat treatment in the air or in the carbon powder, and then we can form the colossal structures, and then we can apply them into the maybe the cancer treatment. So firstly, we needed to perform or confirm about the colossal structure can be formed up with this simple and effective fabrication, and then we needed to performance of the visible light response or maybe of the NIR response. Something like here we designed in this report. So about the experiment, yes, we carried out about the yes in the heat treatment in the carbon powder. The CHT is the heat treatment in the carbon powder. We just mixed about the TIC nanoparticles with the carbon powders, and then heat treatment in them, and then the possible reaction process is something that can be summarized something like this one. The out of the carbon can be reacted with the oxygen from the air, and then thus can form the CO2. CO2 can be diffused out and diffused into the inside, and it can be a reaction with continuous. We form the COX maybe. COX can be reacted with the TI or TIC, and then they can be formed as a titanium dioxide or some kind of carbon doping the titanium dioxide, something like this one. And we designed a series of this experiment. About this one, at the present, I want to report about the result about the we just show here, with different temperature and just for 1 hour. And this is TIC nanoparticles. The XRD result shows that these peaks can be observed to the TIC. And then with the heat treatment in the maybe lower than the 400 degrees C, the TIC peak can be also keeps, and then the antazid can be formed. Time-force maybe very low, but it is shown. And then over the 400 degrees C, the titanium become strong, and then the luthium also can be found. And where the temperature reaches to the 450 degrees C, the TIC peak is almost disappear, and then the antazid and the luthium become stronger maybe. And then with increase the temperature, with the temperature maybe more than higher than the 600 degrees C, the antazid become very strong, and the luthium become stronger. And then the flux of the luthium is something like here, with it is over 600 degrees C. The luthium maybe become more than 4 or 1 and almost certain performance percentage. It means the luthium is higher, and then the mixed luthium and antazid, the activity maybe become enhanced. But we focused on this research. We want to make some kind of the core and the shell structure. So maybe the activity around this one below 500 degrees C, maybe it will be more interesting to make some interesting structure and make the material to be the visible light response, or maybe the NIR response. So we investigated about the UVV's response, something like here. With the temperature, this the sample is something like here. When the temperature is lower than the 400 degrees C, almost the 420 degrees C is the response of the visible is almost something like the TIC. And here shows some kind of response like the TiO2. And with the temperature become to this one 450 degrees C. Here shows the typical TiO2 response, and then here also keeps something like the TiO2, the TIC or carbon doping the TiO2 response. This is very interesting, and this is very important. It can be showed some kind. It means the core shock structure can be formed, and with the temperature come to the 5 degrees C, this is become lower. But here it also means some kind of the TIC response may be. So we focused about the a little lower temperature, and here shows the 400 degrees, and here shows the 412 degrees C. With a long extended the time, here shows the 3 hour, before this is just 1 hour, the 3 hour and a 5 hour. It also show kind of the maybe shows the TiO2 response and the TIC response, and this means that 5 hour maybe enough for the TiO2, and then also keep with some extent of the TIC. That means that the core and the shock structure is forming, and then with a little higher temperature, with long times also it shows something like here. So the next we want to fix out about the more better or optical temperature and time, and then to confirm about the core shock structure and the other activity structures. And for the XPS result, it also show kind of something like this one, the TIC peaks disappear, and then this show also like something like the TIC peaks changes. TIC, this shows the TIC response, and the oxygen is also kind of something like with increase the temperature, the oxygen vacancy is maybe become decreasing. This is because of the oxidation of the TIC. Another one, we also investigated with the team and about the crack structures. Here show up something like maybe a typical TiO2 crack structures. It is difficult to find the column of the TIC. We will try again and then change it about some other investigator method to confirm or to find something about the core and the shock structure. If you can give some advice, it will be very helpful. And another one about the surface area. Yes, we also use investigator black stack, and the result is something like this one. Of course, after the oxidator in the heterogeneity in the carbon powder, it is also with some decrease of the nanoparticle. And when the antazid start to form, yes, it will be show some decrease, a sharp decrease. And then with the TIC is becoming disappearing, the decrease become a little slowly. This 2 point is maybe interesting and is important for the changes of the TIC or for the forming of the TIC and the TiO2 structures. And this show about some kind of the conclusion. This can come to these 3. And this one, the response and the core shock structure can be formed or can be confirmed when the temperature return to 415 degrees C for the 1 hour, or with lower temperature with a little longer times. It also can be form this kind of a structure. Yes, thank you very much.